Hi everyone, we're going to evaluate the definite integral. We're using U-Substitution and half-angle identities. So, first of all, let's rewrite this as the integral from 0 to pi of cosine squared theta cubed. That way we can use our half-angle identity here. And when I rewrite that, I'm going to get this. So you're going to get your 1/2 1 plus cosine 2 theta. I'm substituting here cubed. All right. Now what I can do is cube this 1/2. That's 1/8 and pull it out. So I can pull that out. And now I just want to deal with this cubed. Now basically this has the form a plus b cubed. And that equals a cubed, this is your binomial expansion, 3a squared times b plus 3ab squared plus b cubed. So that's all I'm going to do here is expand that. It's luckily my a is just 1, and my b therefore is cosine 2 theta. So using this formula here, let's expand that. So you're going to get 1 squared is just 1, plus write your 3. 1 squared is 1, so you're just going to copy down your b, which is multiply that by cosine 2 theta, plus we have another 3, and times 1, and this is going to be cosine squared 2 theta, and then plus you just cube your b, so that's cosine 3 cubed 2 theta. I'm going to go ahead and erase this now since we got that part down, so I can have more room. So this is 2 theta d theta. All right, now we can start breaking this apart. So what I want to do is I can break this apart and write this as 1/8. And I'm going to integrate these first two. So we're doing addition for integrations. So this is going to be theta plus, and then you have your 3 times 1/2. And the antiderivative of cosine is sine. So that's sine of 2 theta. And then we're going to integrate it from, or evaluate it from 0 to pi. Then I'm going to go ahead and put the 1/8 again. Integral from 0 to pi of this piece. And that's going to be 3 times 1/2. And I'm going to use my half angle identity again. So I'm bringing out the 1/2. This is be 1 minus, or 1 plus 2 cosine of 4 theta. It's 2 times 2 theta, d theta. So this is just going to be 4. Don't forget to put your d theta. All right, and then for this last piece, I'm going to write it as plus 1/8 over the interval 0 to pi. And I'm going to write this cosine here as cosine squared of 2 theta times cosine of 2 theta. Then I can expand my cosine squared 2 theta as 1 minus sine squared with my Pythagorean identity 2 theta times cosine 2 theta d theta. So let's do that. All right. So now, looking at this, we can go ahead and evaluate this and move on to the next slide. So have this written down. So for this piece, this is just 3/2 here. Let's look at it before I move on. If you plug in pi here, if you plug in pi to this portion, that's going to be 0. You plug in pi here, that's going to be 1/8 pi. Of course, when you plug in 0, that's just going to be 0. So basically, this first little piece here is just going to be 1/8 pi. So let's write that down, 1/8 pi. And I'm going to go ahead and copy down the rest here. So we had plus 1/8, 0 to pi. And then we had 3/2, 1 plus cosine of 4 theta d theta. That's that first part. So let's integrate that. And that's going to give you, so this stands alone for now. So you integrate that. I'm going to pull this 3/2 out. So you're going to get 3/16. And this is going to turn to theta plus, you're going to have to do the 1/4 here. And then and the antiderivative of cosine is sine of 4 theta d. Then we're going from 0 to pi. Now if you look at that and you plug in pi, again, when you plug in pi to this piece, that's going to be 0. And so all we're going to get, and you plug in 0 for this one, you're going to get 0. So basically, this is just going to be 3 divided by 16 pi. So now we're left with this piece and this piece that we're going to add together. So we're going to end up having 1/8 pi plus 3/16 pi. And that's what we have so far. Now let's do that last part we had. So the last part we had was the integral 1/8 we had in front from 0 to pi. And then I had 1 minus sine squared of 2 theta cosine 2 theta derivative of theta. So for that, what I'm going to do is use U-Substitution. I'm going to let U equal sine 2 theta. I'm going to let du equal 2 cosine of 2 theta. I'm taking the derivative of that. 2 theta d theta. So what I want to do is solve for d theta. So d theta is just going to be 1/2 du. All right. So now let's finally integrate this. So when we do that, we're going to get 1/8. I'm going to leave this blank for now. 1 minus u squared. Now remember, cosine, this whole thing here equals, because all you're going to do is divide both sides by 2. So this whole part is just going to be 1/2 du. So let's go to the next slide. So we have 1/8, 1 minus u squared times 1/2, du. The only thing is, we were initially, our integral was from 0 to pi. But since I let u equal sine 2 theta, I'm going to have to plug in my pi here and find my new integral. So sine of 2 pi equals 0. So we're going from 0 to 0. So to integrate that, you're just going to write 1/8, and this is going to be u minus u cubed. Oh, and this is times, let's bring out the 1/2 here. And we're going from 0 to 0. Well, all this just equals 0. So now all we had, and if you recall, the first part we had was pi divided by 8. The second integral we did was 3 pi divided by 16. And then this one is just 0. So our final answer is 5 pi, because this is, you can write this as 2 pi divided by 16 plus 3 pi divided by 16. So all we have is 5 pi divided by 16. And that's it. Thank you. Have a nice day. Bye-bye.